So here we know how to detect objects that are larger than a minimum area. And now we know how to get a region of interest. So I'm showing you just this object. It's a blepharisma in this top right screen, the grayscale image. And there are many features we can extract from this image. One I want to talk to today, which is part of your homework, which is to estimate the texture. And that is the contrast of black and white, the details of the insides of the object, because that should be a feature to distinguish, especially algae, which has lots of texture. So here's a blepharisma from this region of interest. This is the grayscale image. One way to detect texture I thought of is, let's use an edge detector, this Canny edge detector, one line of Python code. And what it's doing is it's taking the grayscale image, which is 0 to 255, and it's determining an edge when the image goes from white to black dramatically. There's a big slope. It'll say that's an edge, and it'll mark it by turning the pixel on. And for on, that means 255. So basically now I want to quantify texture. So what I'm going to do is I'm going to count how many pixels are on. The only problem with that is larger objects that have the same amount of edges are going to be biased because they have more pixels. So to normalize it so I don't discriminate against little objects and underestimate their texture and overestimate texture of large things, I'm going to normalize it. So I'm going to count the number of pixels that are on, that are white, and I'm going to divide it by the total number of pixels. So I'll get a fraction, a percentage of how many pixels are on, which will be a nice indication of how much edges there are, which implies how much texture there is. Okay, so now notice, remember, this is a frame, one image of video, and there's 30 frames a second. In the next frame, your detector is starting from scratch. It'll detect all the objects in the frame. Usually they're the same number of objects, but some objects can leave the frame, some can enter. Because in this microscope, there's really, it's just looking at a tiny area. There's creatures all around this that you can't see. And actually the order is, it basically scans from the bottom right and scans up. So the first object it'll see is this one in particular. And if you notice, I'm printing out the objects. Here's object 1, area 504, aspect ratio 3.1. In the next frame, object 1 is area 156. So what happened? Well, what happened was this object probably got a little lower and this one got a little higher. So in the next frame, the order's reversed. So the object number has very little significance to you. It's really just what order it scanned it in. So this object number has not much meaning to us. So again, the point is, every frame is new to the detector. But what we want is continuity. We know this is a blepharisma and it's swimming around. So when we start identifying it, we want to know as it's swimming, it's still the same object. And that's what tracking does.